In this video, I'll explain game theory. This is for Module 6 for General Education Math. So there are three games that we're going to be looking at: the fair division games, the method of seal bits, and method of markers. In order to understand the games, I urge you to read about the rules. So here are some highlights. So the goods, or its big S, booty. The players are represented by P, so P1, P2, P3, so player 1, player 2, player 3. Capital N represents how many players there are. The value systems, it's in either absolute value, absolute terms, or relative terms. We assume each player is rational. They'll cooperate with each other. That each player has equal rights to share in a set of set S. And the privacy, meaning that the players don't know what other players are going to be doing. So fair share, you divide up the goods or the booty by how many people there are, so N. So capital N divided by N, number of people there are, equals little s. So that's what I mean by small s per person. So there are three types: continuous, discrete, and mixed. You can read about those. So the lone divider method for three players, this is fairly easy. So there's game 1. So you can read about that. One thing about the game 1 is that the Cindy and Cher both want S1 or S3. So it makes sense that Cindy gets either S1 or S3, or Cher gets S1 or S3. But the optimal distribution would be that the Cindy gets the S3 because she values that at 55%, and Cher gets S1 because she values that at 40%. So that would be the rationality assumption. So game 2 is a little bit different. If you play along, Dale doesn't care which S he gets, so let him have S1. So Cindy and Cher both value S2 and S3 over S1. So Cindy and Cher both want S2 or S3. And they both want S3 the most. So in this case, what you can do is combine S2 and S3. So for Cindy, it's going to be 30% plus 50% divided by 40%. And then for Cher, it's going to be 20% plus 70%. So that's 90% divided by 2. That would be 45%. So either Cindy or Cher can get at least, for Cindy, she gets at least 40% of the share. For Cher, that's 45%. So everybody will be happy. Okay, so let's move on to the method of seal bids. This is a little complicated, so I'll have you read the rules. But Grandma is playing a little joke and leaving 4 grandchildren with 3 items: the cabin, the Rolls Royce, and a painting. So how do we divide it up equally so that everybody has a fair share? So let's look at it. So we ask each player to value the items, and here's a summary of the players' bids. So Art, Betty, Carla, and Dave. So that's the first step. You do the bidding. The second step is to move on to allocation. So let's look at the allocation. How do we calculate that? So here's the step 2 allocation. Art's fair share is 135,000. Betty's 130,000. Carla gets 123,000 and 110,000 for Dave. So how do we get those numbers? I did the calculations in Excel, so let me move on to that. You don't have to do calculations in Excel, but for its purpose of demonstration, I did it in Excel. Oops. Okay, so here's a summary. So how do you get the 440,000? You add up all these numbers. So you do that for each player. Okay, so if I do that, each person gets this total value. So that matches up with the table here. So let's calculate the bottom row. So how do you get 135,000? So for Art, the total is 540,000, and there are 4 players. To get a fair share, you do the total divided by how many players there are. So you do 540,000 divided by 4. That's how you get 135,000. Okay, so let's do the same for all players. So Betty thinks the fair share for her will be 130,000. Carla thinks for Carla it will be 123,000. And for Dave, it's going to be 110,000. Okay. In this scenario, Kevin goes to Betty because Betty values it the most. And the car goes to Dave because Dave values that the most. And then painting goes to Art because he values that at the most. Okay. So Carla gets nothing, so let's make everything fair for everybody, including Carla. Okay, so how do we do that? Let's move on to the next step, which is a first settlement. For Art, the fair share of the dollar value is 135,000, but the painting is worth 280,000, so he has to pony up the difference of 145,000 to make his fair share of 135,000. For Betty, her fair share is 130,000, but the cabin is worth 250,000, so you take the difference between the two, and she has to pay out, let's see, 120,000. And for Carla, her fair share is 123,000. She's not getting any items, so she has to receive the full amount of 123,000. And for Dave, the fair dollar share is 110,000. He's getting the Rolls Royce, which he values at 52,000. So he has to have an additional 58,000 coming from him from the rest of the group. Okay, so how do we calculate all that stuff? So the difference will be, for this difference will be 280,000 minus cash. Okay. So I do the same for everybody. So Betty's, the difference 120,000. Carla will be getting 120,000. And Dave will receive 58,000. So then the surplus will be 84,000. If you sum up all these numbers, you get 84,000. So that's the step 3. That's the surplus, or the combination of surplus. So each person gets a fair share of this amount. So 4 people. So you divide this by 4 to get 21,000. Okay, so that's the surplus you see here. So that's what I did in step 4 here. So what will be the final settlement? Here's a summary. How do you get those numbers? So let's look at the calculations. So for Art, he has this much money coming in, but then he has to pay out this much. So the net difference is 124,000. He has to pay out this much money, and then he gets the painting. For Betty, she has this amount of money coming in, but then she has to pay out 120,000. So the difference is outflow of 99,000. That's what the parentheses mean. For Carla, she gets this much plus this amount, so she gets 140,000. And for Dave, he gets this much, and he needs this much coming in, so he gets this amount with Rolls Royce. So this final settlement is fair for everybody. So moving on to, so here's a summary here. I recommend you go through the calculations to make sure you get these numbers on your own calculations. You can do it in Excel, or you can do it by hand with the calculator. So here are some of the constraints. Basically, everybody has to be rich enough to play the game. and everybody will accept the money in lieu of an item. So let's move on to the method of markers. So here's a setup. Basically, you place the markers, and how many markers would that be? Well, if there are 4 players, say, then capital N would be 4. And then how many markers do you need? It would be 4 minus 1, so that would be 3 markers. You cut in 3 places. So how many markers you need? The way to calculate that is see how many players there are and subtract 1. It's just simple physics. Again, the privacy rule applies. And the final step is to give each player one of the segments. So let's look at this with an example. Alright, so Alice, Bianca, Carla, and Dave want to share Halloween leftovers. So there are 20 candies. So we want to be sure that each person gets a fair share. So how do we do that? Well, let's play the game of method of markers. So first thing you do is randomly arrange the candies in order. So this is randomly done. And ask each person to make a bid. Okay. So there will be 3 markers, basically the divisions. So for Alice, for example, let's label Alice's markers as A1. That's the first marker for Alice. A2 for her second marker, and A3 for her third markers. So for example, for Alice, this is a fair share. This up to 11 will be a fair share. And then from 12 to 16 will be a fair share. So to her, it doesn't matter if she gets the first one, the second one, the third one, or the last one. It's equally good to her. Okay, so in summary, Alice is happy if she gets any of these 4 pieces. So 1 through 5, 6 through 11, 12 through 16, or 17 through 20. To her, all these are equal. Same thing for the rest of the players. So Bianca here, first one here, B2 here, second share, third share up to here, and then her last share here. So take a look at it and then understand what these numbers mean. Alright, so then the allocation is the tricky part. The way to do this is you go from left to right. And then you look for the first marker. So one with the subscript of 1. Whoever that is, look for the very first marker. So that would be Bianca's case here because she's the first player with the marker 1 here. So this segment goes to Bianca. That's her fair share. So Bianca's done. So then first player is out. So the next thing you do is look for the second marker. So look for the one subscript with the 2. Whose subscript 2 is the first one to show up along the line. So that's for then it'll be Carla because Carla's the first subscript 2. So for Carla, she has this segment of 7, 8, 9 to be her fair share. So Carla gets 7, 8, and 9. So now the second player is out. So now we're going to move to the third player. So look for the first subscript 3. Then it's going to be Alice. Well, Dave has the same spot as his cutoff segment here. So what do you do if it's both player or 2 players claim the same segment? Well, you just flip a coin. And it so happens that, let's see, Alice wins this battle. So then Alice gets segment between 12 and 16. Okay. And Dave gets 17 through 20. That's his segment. Or Dana. I keep saying day, but it's Dana. So if you keep track of the candies from this original setup here, you'll notice that they're leftovers. These 5, 6, 10, 11. Nobody claimed these. So if that's the case, that's considered to be a surplus. So then you just kind of randomly pick whoever wants to go grab one of these. I personally like M&M, so I'll grab this. But you do that randomly. Okay? So then each person has his or her share, what she considered to be, he or she considered to be a fair share, plus an extra candy, so everybody's happy. So that's step 3. That's how you play this game. And I also recommend you read the generalized version of the rules here. See how this works. And that's it for Module 6.